All right, here we go. Any questions? Anybody want to look at anything in particular?
I had a problem with exercise 1 vectors.
Exercise 1 in vectors? Finding the maximum?
Yeah, for some reason, when I did it, my assertion kept failing.
You want to take a look at it? All right, I gotta find you. Give me a few letters from your.
M-A-R-K.
Say it again.
Mark. M-A-R-K.
Mark. And what's their other?
Say that again. Sarunian. S-I-R.
S-I-R. Is that in your name?
So,
That's it right there. Sarunian. Okay. Yeah, it's one of those names I'm going to have a hard time remembering. All right, so vector assignment exercise 1. And let's take a look there. The assertion is failing. Let's go ahead and just look at that. Oops. Sorry. All right, so the assertion is in failure is in line 28 that the maximum equals 4. So right here, the maximum is not 4. This, you might want to put this into an assertion because this doesn't do anything as it is. You know, if we made that, 444, but it's give us the same result. It has no effect. So you want to make that an assertion.
Don't I have that right there? Assert size.
Oh, down here you do. Yeah, but then this would have no, and that's good down there. So this would have no effect on the running program. See? So actually the size is 0. Size should be 0. It's not even, it'll fail that assertion. So here v.size would be 0 because you just created an empty vector here. Right there, that's an empty vector. So anyway, you could turn that into an assertion if you like, or just take it out. Whatever you want to do there. And here, this maximum, this also has no effect. See, the maximum function returns an int. Okay, that's all it does. So here, when you call it in line 28, returning an int, but what do you do with the int? You get a 4, but you just discard it. So it's very similar to line 18. It just has no, effect on the program. Don't even need that. Don't need that. The one you want is down here. The maximum of this vector is 4. You've pushed back 1, 2, 3, and 4. You want to know that the largest is 4 because this is kind of a special case. It'd be better to put the big number somewhere in the middle to make it more generic. This is called an edge case. But actually, the edge case is good because that may be why your assertion is failing.
Because I have it in order?
Because you didn't get to you didn't look at the last slot. Maybe, I don't know. We haven't looked yet. So, and these assertions, those all look good. So we took this out. Is the vector indeed 1, 2, 3, and 4? Let's check that. Yeah, it's 1, 2, 3, and 4. So we don't need this. It doesn't do anything. This doesn't do anything. But this is the key assertion. This is the key test. The maximum of V should be 4. And so it's not getting to, it's like it's not getting to the last item. So here's the maximum function. So there must be a mistake in here. It doesn't get to the end of the vector. It doesn't look at the last item. That's what I think. Do you see where that's happening? Look at I. I is going to V. We exit the loop when I gets to V dot size minus 1.
So I take out the minus 1.
Yeah. So that should do it right there. Good. Anybody else? So vectors is, that's due like this week, right?
Yeah.
So you want me to talk about application development? Or classes more?
Yeah, can you do the, I was working on the bean jar.
Yeah.
I was
Yeah.
trying to create the program, but it wasn't working for some
Bean
reason.
jar down here.
Yeah.
Well, let's take a look at that one. So that would be in classes. This one, right?
Yeah.
Let me close these here. There's a bean jar. And there's the main, right, in beanjar.cpp. So you're going to put main in there. All right, so now, so this bean jar, so I give this, and I'm asking for, what's the constructor look like? Let's look at the constructor. Well, let me talk about the bean jar class. So instances of the bean jar class are, jars for holding beans. And there's two member variables, the maximum beans that can be held in the jar and the current number of beans that are actually in the jar. So now, if there's a maximum, that means beans can never be bigger than max beans. Also, beans can't be negative either. It could be 0, it could be max beans, or it could be somewhere in between 0 and max beans. So that's the constraint that we have to follow. So this is the data inside a bean jar instance. You could think of it, you've got a cupboard full of bean jars. Maybe you have 10 bean jars in there, and they're different sizes, and they hold different number of beans. I mean, it's kind of a silly problem, but just use your imagination. And so we're going to represent what's in your cabinet with software. So we create these 10 bean jar instances, one for each jar that you have in your cabinet. And they keep track of how many beans are in each jar. And each jar has got a fixed size. It has a variable number of beans, but the size is fixed. And when we create the bean jar instance, we pass in max beans as a first argument to the constructor. So that has to be copied into the max beans member variable. We also pass in a second argument, which is the initial number of beans in the jar before we modify the number of beans in the jar by adding or removing all. So the constructor is going to set, and there's the implementation right there. That's the implementation. So the constructor basically does this. It takes the max beans and that's passed in as the function argument and assigns it to the member variable max beans. That's what this prefix does here. That's what this annotation does here. So if we look at this, here's the constructor. It's good. And these are the max beans and the beans member variables. And here's the constructor. We have to implement that. See, this is, we're not setting, we have to save the max beans and the beans. It's being passed in as arguments to the function, to the constructor function. And we have to set our member variables accordingly. Do you think you can do that?
Maybe.
Yeah, give that a try.
X equals max beans or something?
No. This max beans
Okay.
has to be set to that max beans. This max beans, so it looks like this.
Okay.
This
Yeah.
max beans, the member variable max beans, has got to be set to the max beans that's being passed in as an argument. There you go. It's good. Same thing for beans. That's good. So the constructor is done. Now let's look at this getBeans function. It just returns how many beans are in the jar. So you just want to return beans and you're doing that. Now here, you could say this arrow beans. You could do that, but you don't have to because there's not another variable named beans with more local scope that's overshadowing the member variable beans. So this is good. You could do this beans if you like. Some languages require it. But this language doesn't require it. But of course you have to do it here because there's a naming conflict. This variable and this variable have the same name. So you need a technique to distinguish between the two. That's what we use this annotation for.
So when we say this max beans, is that we're talking about the max beans that's in the private part?
Yeah. This is here's the terminology, right? I want you to use this word. Member variable. It's a member of what? Member of what? It's a member of the bean jar class. These are referred to as members. These are member variables. Sorry about that. These are member variables, line 16 and 17. And these are member functions. So try to use that word member if you can. Now add beans, you pass in the number of beans to add. So this name is actually, we could give it a different name. We could call this N or B or beans to add if it makes it easier to distinguish between the parameter and the member variable. So you could, call this something else, like B, if you wanted to. Otherwise, you got to use this. But this actually looks good what you're doing here. If the current number of beans that we have, plus the beans that we're being asked to add, if those added together are greater than max beans, then we can't do this because the jar isn't big enough. So we return false. Otherwise, we can do it, and we do it right here. Oh, can you indent this? This should be indented, right? Here we go. Remove all beans. Just sets the number of beans to 0. And now down here, you want to fix the indents down here? You can see that? Yeah, good. So now we create a bean jar instance here. So we've got a jar. So this is the variable jar that is a reference to a bean jar instance. And that instance has a max beans of 10 and beans of 5. So we're going to add, we should be able to add 4 beans, right? So add beans will return true here. And so we pass that to assert, so that's good. And in the next line, we can't add 4 more because we have 9 in the jar already. We'd had 5, we added 4. Now we're trying to add another 4, that would give us 13 beans. But the jar can only hold 10 beans. So add beans in line 44 returns false. And we're expecting false, so we negate it here, so then we pass true to the assert function. Some people think this is hard to read, and they would do this. They said, oh, that's easier for me to read. Add beans returns false here. So let me just compare it to false. But what you had was okay.
And you could have done the same for the true part?
Yeah, you could do it for line 43 as well, if you wanted to, if you think it helps in your readability.
On line 31,
yeah.
So can you kind of like translate what that line means?
This right there?
Yeah.
Well, is it the plus equals that you don't understand?
Plus equal, that's fine.
Well, it just says what's on the right-hand side added into what's on the left-hand side. So if the left-hand side was 3 and the right-hand side was 2, well, if the left-hand side was a box with a 3 in it, and the right-hand side was the number 2, well, then you would modify what's in the box from 3 to 5. You would add 2 to the 3 to get 5. So this variables, like this is a variable. It's the name of a box. This is the name of a box. These are all names of boxes. And what I mean by a box is just a section of computer memory that's storing a value. So we can take, if we've got a 3 in there now, we could take the 3 out and put a 5 in there. So this is what it does. This modifies what's in the box on the left-hand side. It takes, whatever in there, it's going to take what's on the right-hand side and increase it by that amount. Another way to write this is like this. You can write it like that. You take this dot beans and you add to it beans, and then the result is stored into this beans. Oh, that's an equivalent statement.
I like that.
Yeah, save that one, good. Now down here in these assertions, you might want to check how many beans are in the jar. I recommend calling get beans after add beans and checking that the value is what we expect it to be.
So
Think you can do that?
So it would be assert.
Yeah. Yeah, that's right. It doesn't take any argument. No, no, no. Get beans doesn't take an argument. See, get beans is just devoid argumentless there.
That?
So what should get beans return? Yeah, 9, exactly. Well, maybe what about after line 44? What should maybe just drop line 46 into line right after line 44? Yeah, copy that. Good. Well, not cut it, copy it. Yeah. And put it in line 47 as well. I mean, there's, have it twice. Yeah. So we perform the operation add beans should, in line 44 is going to modify the beans in the jar. It'll become 9, but the second time we call add beans, the value won't change. So get beans will return the same value. So I think the problem was to implement the a test code for add beans.
Because it's still failing.
Oh, it's failing. Huh? So where does it fail?
Just actually,
Huh?
now it's working.
Oh, it works? Okay.
Now it's working.
So this passes. All right, that's it. That's good. Keep practicing these. It's the very beginning of programming with classes, so it's just a very, very start. It's hard to make a strong case for using classes in code at this point, but when the programs get large in size, it makes a lot more sense to organize the logic into classes. Or any other questions or suggestions what we should do here?
Quiz review.
Is that?
Quiz review.
Right, you might be reading.
Quiz review. We go
Quiz
over some
review?
of the quiz questions.
So what's coming up on the quiz?
Yeah.
Is it vectors?
Yeah.
So vectors are going to be on the quiz?
That's next week's quiz.
Is that next week? Sure.
Wait a minute.
This week's quiz is classes.
Next week is classes?
No, this week. Next week is vectors.
Oh, so this week is classes. Next week is vectors. That's right. That is right. So classes, you're going to have to answer those questions. Like this, like these are the answers. So for that bean jar class, here's the answers for the bean jar class. The first question was, look at this. I gave this code, and then I asked, draw the UML class diagram. So the answer would be this diagram here, bean jar, right here. There's 3 sections, 1, 2, 3. And the top section is just the name of the class. The middle section are the member variables, and the third section are the member functions. This little symbol means public, the minus sign means private. It just happens to be that all the member functions are public rather, and all the member variables are private. That's what happens to be in this case. But a member variable could be public, a member function could be private. So those scoping rules, those scoping indicators can be applied to flexibly to both variables and functions. And we have the name of the function followed by the parameter list, but the parameter list You've got the parameter name first, followed by a colon, and then the data type of the parameter. And if the function returns a value, then you have the colon at the end of this, followed by the data type that's returned. See, remove all beans doesn't return anything. It's a void function. So we don't show it returning anything. If you wanted to, you could put colon void there if you wanted to do that. And notice remove all beans takes no arguments, just like get beans takes no arguments. But add beans takes one argument, and the bean jar constructor takes two arguments. The arguments are separated by a comma. So, and that's the first question. And the second question is provide an implementation of the bean jar constructor. So, this thing. Oh, by the way, in the problem statement, it shows you, I give you this code, okay? But then I give you this paragraph here. This paragraph describes how the bean jar class operates. It's got a member variable named max beans that represents the capacity of the jar, and so on. So you read this description of the class. You need to read the description of the class to know how the class works. And then I'm providing this code, and I'm asking for the UML class diagram. But I could have done it the other way. I could have provided the UML class diagram and asked you to provide this code. Or just given you the UML class diagram and asked you to implement the functions. So here's the first one. Number 6, implement the bean jar constructor. Now, I don't want you to have to do a lot of writing on the quiz or on the final. So you just need to write the contents of the constructor. You don't have to put the constructor, function name and the argument list, because that's already provided. So you don't need to copy that. It's 2 lines right there. If you wanted to copy the body, the header to this, if you wanted to copy this down there, no, not that one, but if you wanted to copy this to show it as, the beginning of your constructor definition, you can do that on the test. It's not a problem. You just don't have to. And then the next problem is to provide the implementation of the getBeans function, number 7. And it's just return beans. Looks like my numbering is off here, isn't it? It's 1 through, oh no, it's okay, 1 through 7. Return beans, that's it. That's get beans. That's all you need to write down. That's all the get beans function does. Just returns the beans. And then there's, what about the implementation of remove all beans? This function. Number 8. Removing all beans just means setting the beans variable to 0. Remember, this is a member variable. And then finally, the last question is to provide an implementation of the add beans function. Oh, it's not the last question, second to last. So here's one possible implementation. There's other ways to organize it. You could make this into an if-then statement. If-else, rather. You could organize it as if-else. Or possibly have a different organization as well. You don't need to use plus equals here. You could use that other form I showed you. This beans equals this beans plus beans. If you want to rewrite the function, you can do that as well. If you wanted to take add beans here and change this name to X, or B, maybe B is better for beans. You can do that, and then you wouldn't need to use this arrow to distinguish between the two conflicting names. You can do that if you like. It's more writing for you, but that's it. I'll accept that. And then finally, develop test code to test the add beans function. I'm not asking you to test the remove all beans function. I'm not asking you to test the get beans function, although it's useful to use get beans. And use assertions when you answer this. So we need a bean jar instance. This is the code you had actually in your Mark, that you had this code in your thing. And this is acceptable on the quiz. But for the assignments, I'd want a little bit more, right? I want you to test that, that the number of beans in the bean jar is 9 after doing this. But you don't need to do it in the quiz. I just want to see that you understand how to create an instance of the class, how to call functions, and how to use the assert function to verify that the test is passed. That's what I'm looking for. But I'm looking for one more thing in there. I'm also looking for test code that provides good coverage. And what I mean by that is that your code executes all lines of code. Well, this is the add eggs function, but it's the same over here. Your code should execute all lines of code in the add beans function. So the test code should hit this point and should hit this point. So it'll hit this point. If you pass in a value that's too big, you'll hit that point. And you'll always execute the if statement. This always runs. But if the condition of the if statement is true, then you're going to return false, and you won't end up doing this. So you want to make the if statement true so that you return false, and then in the next test, you want to make this condition evaluate the false, so you don't return false, but you end up doing the next line. So that's what I mean by good coverage. Every expression in the code should run, should evaluate. So any other questions about classes for today's quiz? Nothing? Question? Did you want to look at your stuff again?
Exercise 3 on vectors.
Number 3, vectors?
Yeah.
Do you want me to just talk about it, or do you want me to look at your code? Okay, let me take a look at it. Hold on. All right. That one, right? Okay. Okay, so let's look at vectors here. Number 3. Probability of a prime number. Oh, this is a good one because it uses the number class. This is a very good one to look at. So we got to implement this function count primes, and it takes a vector of number. See, the number class is got, that is prime function on it, so we can use that. And then I give you the test code. Here you create a vector of number. And we're going to test uppercase N. It's 100,000 numbers. We're going to randomly generate 100,000 numbers. And we're going to count how many of them are prime. So we have a loop that goes, starts at 0 and goes up to 100,000, and then it terminates at 100,000. So that's 100,000 executions of the body of the loop. This will run 100,000 times. Now, what do we do in there? Well, we have a do while loop here. So we're going to generate a random number r. So we declare r here, and then we're going to set r to some random value, random integer. But the number won't make sense if it's a 1 or a 0. Then those aren't good numbers to test a function with, although we could write the function as prime to return, say, false on 0 or 1. But I'm skipping that, so I'm testing. So if r is less than 2, if it's a 0 or a 1, then we're going to generate, we're going to call rand again. We're going to keep calling it rand until it returns a number that's not 0 or 1. That's how I did that. That wouldn't be necessary if we implemented that is prime function, if we had that return false for 0 and 1 specifically, but we didn't do that actually, so I wrote it like this. Now once we get this r, this random integer r, we pass it into the number constructor. So we create a number instance with the r in it. It's called a wrapper class. And we're passing in this integer r, and this number instance is going to give us information about r. And so when we create this number object, we'll push it onto v. And we can do that because v is a vector of number. It's not a vector of int, it's a vector of number. See? That's the data type. So the only things we can push back onto v are number instances. The compiler won't let us push back r directly, so we have to create the number object and push the number object onto the vector. So once we do that for 100,000 numbers in this loop, then we're going to call count primes. That's the function that you need to implement. We're going to call count primes. And it counts the number of prime values in v. So you can just imagine this function here. It's going to iterate through all, v of 0, v of 1, v of 2, v of 3, like that. And for each of those, it's going to do v of I dot is prime. So v of I dot is prime return is true. Then we're going to increment some counter. And then when we're done iterating through all this vector of number, we'll return that counter value. So this is how many numbers in v are prime. And we divide that by 100,000. That gives us the percentage of primes in this interval, our estimate of that, because we didn't calculate all the primes in the interval. We just calculated 100,000 of them. The percentage of primes in there is that. Just like the probability that a value is prime. I think it's somewhere around 5%, something like that, I don't remember. Oh, look at your code. Okay, so everyone is now hopefully up to this point. Is this it here? This is the number class.
That's the vectors.
Yeah, so we need this, right? We need to.
Okay,
Are you using this one?
yeah, I use what we got from my classes and.
Oh, I see. You put it in here. Okay.
But when
Right.
when I run it, it says there's an error on line 39. Count prime v.
That one right there.
Yeah, I don't know what's wrong.
It doesn't like that, huh?
Yeah, I ran it. I fixed it a lot of times, and then when I finally got it, and then when I ran it again, there was an error on line 39.
39.
The count prime v.
Count primes V.
It said it was not declared in the scope.
Yeah, I don't see it. It's not there. You didn't implement it.
Uh,
Oh, in here. No, this does not belong in the number class. This is a function that's external to the number class.
also, I wasn't.
So you want to define this count primes function should be, maybe put here. Yeah. You have to use the curly brackets to, implement it. There we go. And then you got to return some integer. You just return a 0 for now. That's a stub. Okay, so your job, the whole purpose of this assignment, well, not the whole purpose, but part of what you have to do is implement count primes. So it's not a member of the number class. So we took it out of there. That's good. It's let me check your number class here. Yeah, that's good. Oh, this you're using uppercase N here. This should be probably lowercase n is better. Here, this uppercase N is not inside the class. It's meant to represent like a constant. In fact, I should have done this. Let me fix that. I should have said this. Const int n. I'll fix that right there. I should have just said that this is just a constant. I use uppercase. Sometimes we use uppercase all uppercase to represent fixed constants in code. Yeah, to make those lower n, that's good. That's very good. And they have different, it would have still worked the same way because this n here its scope is completely separate from, the inside of the class, number class. So it would have, it's just documentation. It's just readability at this point. So now, does this compile?
Yeah.
It compiles, but it won't run. Right? I mean, it'll give us a 0, right? When you run it, let me run it. You're inside vectors, right?
Yes.
So when you run it, it says 0 because we're just returning a 0, right? But now you need to actually count. You have to iterate through V and determine how many of those values in V are prime numbers. And you're going to use the isPrime function, see? Can you do that? You got to use a loop, right? And then stuff like int I, and,
So
start 0. That's the first position in V. And go all the way up to v.size. You don't need to use uppercase N because you got the size of the vector, in v.size. There you go. Whoop, that's a function call. v.size is a function call. Yeah. Open, close parentheses. Oh, no. The function calls always have parentheses at the end. So you don't have to put v.size in parentheses. You have to look at this. V dot pushback, open parenthesis, parameter, close parenthesis. Yeah, that's it. You got it. That's good. The return we'll worry about later. There we go, good. Very nice. So you've got, v of I. No, you're not doing. See, you don't have to duplicate this logic. It's already inside this function. You're just going to call is prime. So, you've got v of I. No, you had it right there. The if statement is good. I'll put that back in there. Yeah. So you got to look at v of I. V of I is the ith. No. You don't do any modulo stuff there. You don't have to do that. Just v of I. V square bracket I. And then call dot is prime and see what it returns. Yeah, there you go. vi and then dot is prime. There you go. And then open close parentheses. That's a function call. And no return statement there. So you want to know if v of I is prime. If it is prime, then increment some counter. So let me do that for you here. I'll implement this. This is the count. And we'll set that to 0. Okay, so if v of I is prime, if that returns true, then increment the count. And then when you're done, return the count. See? That's how that works. So this is a function call, so you've got to remember the parentheses. Is prime is open close parentheses. No, don't you remember we did it here? V dot size and v dot pushback. Here you go, v dot prime. Now this, you don't put a semicolon there because then it'll do nothing. Yeah. Now what happens if that condition, v of I dot is prime, what happens when that condition is true? You should increment your counter, the count variable, because you're counting a number of prime values. How do you increment count? I want count to be 1 larger when that expression vi is prime is true. No, not a return. You're not returning. Increment count. Do you know what I mean by increment?
Plus.
As 1. Plus, yeah. Adding 1 to count. There you go. You need the semicolon to end the statement. There you go. That's it right there. That should work. I think that's finished. See, the purpose of this problem was to sort of see how classes might be used, give some context in which classes are being used, and other than test code. It's not the best example, but it's, I thought it was simple. So it's good. It's fine.
It's saying there's another error.
You say what?
It's saying there's an error on line 30.
On that line right there? There's an error on line 30?
Passing constant value type, type, aka constant number.
So, well, let me take a look. It's EX3? Oh, I'm in the wrong. It's in vectors, right? Line 30. passing const number as this argument of is prime. Passing const number as this argument. Const number. What? I don't get it. What's going on there? This is this is the is prime, right? This is a vector. Oh, const. This is good. All right, so that means the problem is, I know this is hard to get. This one's hard to get. See, you're saying that V is a const parameter. So that means it's a promise to the compiler. You're saying, compiler, I will not modify V. Promise not to modify V. In my code, this is my code in here. I will not modify V here. But the compiler is saying, hey, you may be modifying V right there. Well, we're not, right? We're not modifying V. And the reason the compiler doesn't like this right here is because is prime was not declared const. And because is prime is not declared const, the compiler is saying, hey, you're calling a non-const function on a const object. So that means you may be violating your promise. So we have to make is prime const. See? Can you do that? Well, let me do it. I'll show it. See, this is const. Is prime is going to be const. That makes this problem hard, doesn't it? Does it work now? I'll try it too. And we got to have to include, what is it, C standard line?
Actually, on Monday, when Mark was helping me on the first one, he said that after I type in the C++, I do dash ST equals C++ when I'm trying to compile it.
That's a different problem. He was, not this problem, that's a different problem. That was a different problem he was talking about. So you need to include the is it C standard line? I can't remember now. I just don't remember. Wait a minute. That was it. Just a header. But the one that you're talking about is a different problem. Actually, Mark told me about that, believe it or not. So I remember, I know what you're talking about. So that's, am I missing something on this assignment here? So this is declared as const, right? You know what, I better put this. Did anyone get exercise 3? I haven't tried it, so let me put a warning in there. Thanks for helping out with that. Is it? Your name is Furton?
Yes.
Furton. Oh, I got it. Okay. And so Furton, thank you for bringing this to our attention. For this to work, use the number class, and then I want to say note. The is prime function of your number class should declare const. All right, that's a note. Because the number class, maybe I didn't explain that well enough. This is the number class. This is prime. Exercise 2. See, here, these, let's see, get beans is const. You see that? But add beans is not const because add beans modifies the member variables. But get beans does not modify any member variables, so we declare it as const. So I am covering this. And in the egg carton, I don't, yeah, anyway, that's there. Okay. All right. Anything else? We're at the end here. All right.